Okay, we ready? Here we go. We got a lot to do, little amount of time. Let's talk about a couple things. When do we get out of here? 1:25? Wow, I only got 10 minutes. You kidding me? Goodness gracious. All right, let's try this. Here we go. Ready? Guys. All right, let's talk about a couple different angle variations here. Oh, I'm on the wrong lesson. Let me get to the right lesson. All right, there we go. Let's talk about this kind of an angle. Let's see, like that. All right, let's call this angle 1. Let's call this one angle 2. We have a name for these kind of angles. Let's say it connects right here. We have a name for these angles. It looks like these angles are next to each other, and there's a big fancy word that we use for things that are next to each other, and we call that adjacent. Alright, so these are called adjacent angles. That's just my abbreviation for angles. So 1 and 2 are adjacent angles. It doesn't mean they're necessarily equal to each other, does it? It just means this ray is inside these two rays. And if you have that situation, then they're adjacent angles. Look what has to be true about it. They have to share a common vertex. Do both of those angles have the same vertex? Yep. And they have to share a common side. Do they share a common side? Yep. Angle 1's got this side, and angle 2 also has that side. There's something else that's true, but I'm not going to get into that right now just because of the time. This is 1:5. So let's do another situation. Watch this. It's up here. Look at this angle right here and look at this one right here. Do you think they're adjacent angles?
No.
What did I had to say was true? They got to share a common endpoint and share a side. Do they have a common endpoint?
No.
Angle 1 and 2? No, they don't. So these are non-adjacent angles, or we just say they wouldn't be adjacent angles. All right? Easy enough, right? Let's do another thing. Kind of touched on this a little bit when we worked on these problems on the board, but we haven't officially talked about it yet, so let's officially talk about it. Look at this angle. We'll call this 1 and 2 again, for lack of imagination. Look at what these two angles do together. These two angles, if I went all the way here to 1 and then I went all the way here to the end of 2, what would they form? Say it. 180 degrees. That's right. They form 180 degrees. Watch. From angle 1 is that much, right? And angle 2 would be all the way to here. What does that form? It forms 180 degrees, or a straight line. That's right. Okay? That would be a straight line. Here's what they call it. When you have two angles and they form 180 degrees, we call this a linear pair. It's supposed to be an R. Linear pair. Alright? Linear, because the word line in there. Do you see that word line in the word linear? And pair meaning what? Two. So there are two angles that make up a straight line. Not 3, not 4. And it's not just one angle. I'm not talking about just that angle. So watch. Let's put some points in here. This is a common mistake. People in my honors class made the same mistake. Watch this. I said there might be a problem on a quiz or test or something that says name a linear pair. So what would the linear pair be? Forget the numbers. Just pretend you didn't have the numbers in here. What would the linear pair be? What would angle 1 be? D, B, C, right? What would angle 2 be? A, B, D. Or you can go the other way. It doesn't make any difference. I had some people saying, excuse me, that the linear pair was angle ABC, and that was it. If it says linear pair, how many angles do I need? I need 2. So just putting down one angle already means it's not going to be correct. You agree with that? Okay, so if I called a linear pair, they have to be 2 angles that form a straight line. So ABD and DBC would be those 2 angles. You got it? Okay. Let's go on to this. I'll try to squeeze this all onto this one page. What if we had 2 angles that intersect each other like this? Let's call that angle 1 and 2. Let's call this one over here 3 and 4. Look at 1 and 2. They kind of have a relationship, don't they? It looks like they're across from each other. Wouldn't you say that? Like if I went here and I said go across to the next angle, what would you do? I'd probably go jump over here like this. You see it? Kind of straight across. Well, we don't call them across angles. We call them vertical angles. Yep, you would. So 1 and 2 are across from each other, and 3 and 4 are also across from each other, so they would also be considered vertical angles. I had somebody in one of my classes, I think it was in the honors class, they said, well, would you call 3 and 4 horizontal angles because they look like they're across from each other horizontally? It's a good idea, but we don't. Any angles, doesn't matter what if they're completely up and down or completely left and right, excuse me. We call them vertical angles. So 1 and 2 would be vertical angles, 3 and 4 would be vertical angles. Now, just take a look at it. What do you think might be true about angle 1 and angle 2? Just guessing. Okay, they do share a common endpoint. They're not adjacent angles though, are they? 1 and 2 are not adjacent angles. But what as far as the measurement of angle 1 and the measure of angle 2? Looks about the same, don't they? And they are. Okay, anytime you have two lines that intersect each other, the angles across from each other, the vertical angles, will always be the same. So I could set angle 1 equaling what? Angle 2. Now in geometry, a lot of times we don't say equal. What do we say instead of equal? Congruent. And put a little squiggly. Did I show you that the other day? Okay, put an equal with a little squiggle on top. That's a pretty ugly one. Try to make it a little bit better. Equal with a little squiggle. That means congruent. It basically, for as far as as long as you're concerned, it just means equal to each other. All right. So angle 1 equals angle 2, or you can say congruent. Now, what about angle 3? What equals angle 3? Angle 4. That's right. Or you could say angle 3 is congruent to angle 4. It's a big thing we say in geometry is congruent. Make any sense? Yeah. What if we had this? What if we had a line like this and a line like that? Now remember our situation here. Our situation is we only have vertical angles if we have two lines that intersect each other. Now look at this. This is not just two lines though, is it? You've got one line right here, but is this a line, this whole thing from here to here? No. Right, it kind of splits. It's not straight, is it? So we can't say this is a line. So if I said this is angle 1 and 2, could I say angle 1 and 2 are equal to each other? No. A lot of people make that mistake. Remember, this only happens when two lines, two straight lines, form those angles. That's the only time 1 and 2 and 3 and 4 will equal each other. Does that make sense? All right, make sure you look at that because a lot of people make that mistake. They'll say, oh, 1 and 2 are equal, they're vertical angles, and 3 and 4 are equal, they're vertical angles. Nope, because angle 4 isn't made up of the same two lines as angle 3 is made up of. Got it? Okay. Let's move on. Let's get rid of all this. And we've got a couple more things to hit. We've got about 3 more minutes to do it in. The next one it's kind of like what we talked about before. What does this look like that we just talked about not long ago? Looks like a linear pair, doesn't it? Okay, but let's do this. If I said that angle 1 and 2, what do they do? Angle 1 plus angle 2 do what? They add up to be? No, come on. Think before you say something. Angle 1 plus angle 2 is equal to what? 180 degrees. All right, everybody got that? What did we say they were? We said it was a linear pair. But we also can say this, that angle 1 and 2 are supplementary angles. Any two angles. Actually, I don't know if it's just 2. In the other class, I said it could be more. Let me just say, yeah, it does say 2. Anytime you have two angles that add up to 180, we say those angles are supplementary. In the last class, I said it could be 3 or more, or 2 or more, but it's only 2. I just looked it up. Supplementary. So supplementary angles are angles that add up to 180 degrees. Well, we also have a word if the two angles, this is another popular angle that's used a lot. What would this be? If I put a little box right there, how many degrees is that? It's 90. Okay, and what about this? Angle 1 and 2. They're not called, what do they do though? Angle 1 plus angle 2. They don't add up to 180 in this situation. What do they add up to be? 90 degrees. Anytime two angles add up to 90 degrees, we call them complementary angles. Complementary. All right. Again, this is just vocab. It's just we're going to be referring to this a lot. I'll say these angles are supplementary, these angles are complementary. You got to know in your head what I'm talking about when I say that stuff. Does that make sense? One more thing, and if you have two lines and they intersect each other at a right angle, you notice? See, look, these are two lines. They keep going this way, they keep going this way. They intersect at a right angle. We have a special name for that type of those two lines. We call them, and this is probably a word you've heard before.
Teachers, please excuse
but we call them perpendicular.
All those students who receive duckies, it's going to be time to feed the ducks in about 1 minute. If you received a duck, please come to the upper school lobby.
They're called perpendicular lines. Here's a little symbol for perpendicular. Let's say we'll call that line L, and we'll call that line M. This is the symbol for perpendicular. We would say that line L is perpendicular to line M. Do you see that? That's the symbol for perpendicular. All right, let me give you a worksheet, and then you guys can head on out.